All right, so this is going to be part C of the free response item. And it says for 0 is less than or equal to T is less than or equal to 20, the average temperature of water in the tub is given by 1/20th integral from 0 to 20 of WT, which is our average value function that we have, 1 over B minus A integral from A to B of the function we're trying to find the average of. This says use a left Riemann sum with 4 subintervals indicated by the data in the table to approximate that value. Does this approximation overestimate or underestimate? So in part C, we are looking for 1/20th integral from 0 to 20 of W of t dt. All right, so it said a left sum, so I'm going to get the 1/20th out there. And it said 4 subintervals, so I'm going to set up a template like I always do. All right, and this would have 4 rectangles. All right, and we've got our structure set up. Now we're going to have to lean on the table quite a bit. All right, so I'm going to go up in the table, and the first subinterval has a width of 4. All right, and it specifically set a left Riemann sum, so on the left side of that we're at 55. All right, the next one had a width of 5. All right, and on that interval, it goes from 4 to 9. We have 57.1 on the left side. All right, the next one goes from 9 to 15, so that's a width of 6. And on the left side, we're at 61.8. And on the last one, we go from 15 to 20, so that's a width of 5. And on the left side, we have a 67.9. All right, so if I take that to my calculator, I'm going to get 1 over 20, all right, times 1215.8, which equals a 60.79. All right, so we're looking at 60.79 for that estimate of that value. They said nothing about context, so we're not going to put this in context. They told us exactly what we were finding on this one. But what they did ask us, they said, is this an over and under estimate? All right, so it's a left Riemann sum. So we know that if a function is increasing and we go with left sums, we're under. If a function is decreasing and we go with left sums, we're over. So this is where that one line that we underlined way back at the beginning, all right, strictly increasing, is coming into play. All right, so this is increasing, so left sum is going to be below. So we're going to say the approximation, right, is an underestimate. All right, so that's what we found. All right, and the reason is because a left Riemann sum is used and W of t is increasing. All right, so we've established what we need to, and we've got everything there for part C. All right, so that's part C. Again, they're testing left Riemann sum. They're testing the fact that you know that strictly increasing tells you it's going to be an underestimate on this one. And they alluded to average value, but technically they're not testing it here because they didn't really ever ask you to come up with that formula. If I wanted to make this a little bit richer question and test yet another skill, I would probably just frame the question as find the average temperature of the water in the tub over the time from 0 to 20 using a left Riemann sum, and leave it up to you to come up with the 1 over 20 integral from 0 to 20 W of t. But again, that's if I wanted to make the question a little bit richer, I would have gone and left it that much more open. So you might look for that on this test because they're trying to cover a lot of stuff in just a few questions. All right, I hope that helps. Thanks.